Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is the next periodic property, that is electron affinity. What is the meaning of affinity, children? Obviously it is attraction. Attraction for what? Electron. Now for this, we'll take one simple example. What is that? Chlorine atom. What is the electronic configuration of chlorine? It is 2, 8, 7. Now, it has 7 electrons in the outermost shell. Obviously, it will accept 1 electron because after accepting 1 electron, it will attain what structure? Octet structure. Now, children, how many chlorine atoms have taken? 1. So, that's why I'll call it as what? Isolated. Do we have any charge on the head of chlorine atom? No charge. So, I'll call it as what? Neutral. Then, obviously, this chlorine atom is in what? Gaseous state. So this will accept 1 electron, right? Where this electron is getting added? Outermost shell of chlorine atom, and it will become what? Cl minus, which is nothing but what ion, children? Anion, right? And the configuration of Cl minus is 288. After accepting the electron, it becomes anion and it releases some energy. That energy we call it as what? Electron affinity. Sir, it is not clear. It's very simple. Assume that I am chlorine atom, right? This is the electron what chlorine atom is accepting. Yes, I accepted. Then I became what, children? Cl minus. Then after that, I will release some energy. That energy we call it as what? Electron affinity. So, conclusion from this one is electron affinity is the amount of energy released when an electron is added to the outermost shell of a isolated neutral gaseous atom to form a what ion? Anion. Right, children? This is electron affinity. Now, children, this electron affinity depends upon what factors? So, it depends upon 2 factors. One is atomic radius and the second one is nuclear charge. Right, children? Now, observe here. First, we'll straight away proceed with atomic radius. So, for that, what I will do is that I will consider 2 atoms. Children, we all know that in any atom, we have a nucleus. The charge of the nucleus is positive. That is due to the presence of what? Protons. Right, children? Now, I have considered one bigger atom and I have considered one smaller atom. Children, both the atoms have got electrons in the outermost shell, right? Now, the distance is more, that is the atomic radius of this one is more. Distance is less, that is the atomic radius is less. Now, children, first, let me try with this one. I want to add the electron to this atom. Now, question arises, sir, the charge of this electron, what you are adding, that is negative. And already this atom has got electrons inside. No, the charge of that one also is negative. Sir, there won't be repulsion between these two, these electrons and these electrons. Definitely there will be a repulsion. If there is a repulsion, then how can an atom accept the electron? No, it will accept. Why? Because we have a dash nucleus which contains what? Protons. So between this and this, we have what? Attraction. So because of that attraction, it will accept the electron. More the attraction, right? It accepts the electron readily and it releases what? More energy. Less the attraction, right? It will not accept the electron readily and it will release less energy. Right, children? Now, children, in this case, right? What happens is that because the size of the atom is what? More or bigger size. In this one, we have more of what? Screening effect. Sir, what is the screening effect? Children, I have already discussed about this screening effect in the previous videos. Again, let me recall it. Screening effect is nothing but the decrease in the force of attraction between nucleus and the outermost electron by the electrons of inner shells. This is nucleus, outermost, right, electron, and this is the electrons of what? Inner shells. So these people are acting as a what? Screen between nucleus and outermost electron. See, 3 screens are decreasing the force of attraction. So because of this screening effect, the attraction between this and the electron will be less. So this atom will not accept the electron readily. So that's why the bigger atom will what? Release less energy after accepting the electron. Now come to the smaller atom. In case of smaller atom, what happens? See, between the nucleus and the outermost electron, how many shells are acting as a screen? Only one shell electrons are acting as a screen. Now, if I want to add electron to this one, obviously between this electron and this electron, definitely there will be a repulsion. But between the nucleus and this electron, there will be a attraction. Now, when you compare here, when you compare this with this, here the force of attraction between nucleus and outermost electron is more because of less of what effect? Screening effect. So that's why this atom, that is the smaller atom, attraction is more. The smaller atom will accept the electron more readily and it will release more energy. That is, the electron affinity of smaller atom is what? More, and the electron affinity of bigger atom is what? Less. So then what is the relationship between atomic radius and electron affinity, right? So it is something like this. What is this? Greater the size of an atom, right? It will not accept the electron more readily, and the energy what it releases is what? Less. That is this one. Smaller the atomic radius, right? This one accepts the electrons readily because of more force of attraction. Then it releases more energy. That is, electron affinity will be more. This relationship we call it as what, children? Inverse relationship. So conclusion from this one is, generally the smaller atoms will accept the electrons more readily when compared to the bigger atoms. This is general. Few exceptions are there. Now children, what is the next factor that is going to affect electron affinity? That is nuclear charge. Very simple children. Nuclear charge is nothing but the number of protons present in the nucleus of an atom. As the nuclear charge increases, so then the electrons are attracted with what? Greater force. Then it will accept the electron readily and it releases more energy. That is, the electron affinity values will be very, very high. So the relationship between nuclear charge and electron affinity is what, children? Direct relationship. As the nuclear charge increases, that atom will accept the electron most readily and it will release more energy. That is, electron affinity will be high. Right, children? Now, the last thing is that electron affinity values suggest what? Definitely, based on the electron affinity values, we can make out how readily that atom accepts the electron. If the electron affinity values are high, then that atom accepts the electron most readily, right, when compared to the other atoms. And finally, the conclusion is the electron affinity values are going to depend upon atomic radius and nuclear charge. I hope you have understood whatever I have discussed, children. So remaining things will continue in the next video. Thank you, children. Namaste, everybody.